morning, good morning, or afternoon, or evening. Finding rate of change using the graph. Today we're going to get with the idea of what is slope. So slope is the same as the rate of change. Now when given in a graph form, it's like your change in y over your change in x. So it's the vertical change over the horizontal change. And typically it's written as a fraction. So looking at this first example, the graph shows the altitude of an airplane as it comes in for a landing. Find the rate of change. Explain what this rate of change means. We just need 2 points on here. Looks like they gave us 2 points. So vertically, let's look at the labels here. It went from 1,000. Oh, by the way, I'm looking at this point and this point here. So vertically, it went from 1,000 down to 0. So it dropped 1,000. And the label there is feet. So in that time that it dropped 1,000 feet, it went from 60 seconds to 180 seconds, which that means it went up 120 seconds. Now you always reduce the rate of change if you can. I see that both end in 0, so we can chop off 0. Now you have 112, which those are both divisible by 4. So that would be negative 25 feet over 3 seconds. Now, the nice thing about this is like it kind of tells you what it means. It means the plane drops or descends. I think that's how you spell descends. 25 feet every 3 seconds. So again, it's the vertical change over the horizontal change. So let's try another one here. So this is a moving automobile. If you look at the labels here, it's the distance traveled in miles in the time per hour. We could pick any points to work on. If I was really doing this, I would pick those first 2 points just because they're the easiest. But again, we could choose any one of them. Let's say we pick this point and this point. So from 0 up to 250, it went up 250 miles. It went from 0 to 5, right? In the time, right? If you take that down, it went from 0 to 5. 5 hours. Now, if you reduce that, or in this case, just divide it, 250 divided by 5 is 50. So it comes out to 50 miles per hour, for 1 hour. So what does that mean? That means the automobile is traveling at 1 L or 2 L's, I don't know, at 50 miles per hour. Cool. When it's labeled, it's nice because you can tell what it actually is referring to. A lot of the times we're just going to be looking at a coordinate plane, which you're checking that vertical change over your horizontal change, or it's often called the rise over run. Now, I always go from left to right, just like I'm reading the book, and if it goes up and to the right, the slope is positive. If it goes down and to the right, the slope is negative. So let's look at some of these graphs here. So going from negative 2, 1 to 3, 4, let's kind of turn it into a triangle almost. We're rising up 1, 2, 3, and we're running over 1, 2, 3, 4, 5. So we rose 3, and we ran 5. That's it. 3/5 is our slope. Now always make sure you simplify it if you can, but we can't on that one. Now this one left to right is going down. So if it goes down, that just means the slope is negative. So we went down 1 and over 1, 2, 3, 4, 5, 6. So our slope would be negative 1 over 6. So I have 6 here on the notes for you to try. They're on the blank notes for this. So I'd like you to actually pause it here and try to find the slope, see if we come up with the same thing. Here this is up 1, 2, 3, 4, 5 over 3, 5/3. And this is down 1, 2, 3, 4, 5, 6 over 3. -6 over 3 would reduce to -2 over 1, which is just -2. Here we're going down 2 over 3, -2/3. Here we're going up 1, 2, 3 over 1. 3 over 1 is just 3. Here we're going up 1, 2, 3 over 2. 3 over 2. And here we are going up 1, 2, 3, 4. 1, 2, 3, 4 over 3. Sweet! And the last way we're going to calculate slope is just given the coordinates. So there is a formula for it where you're subtracting the y's up top, and you're subtracting the x's on the bottom. So the way I like to think of it is like a picnic table. Right, you got the legs of the picnic table down here, and then you've got the fancy glasses up on top of the picnic table there. Now it says y sub 2 and y sub 1. You don't have to square it or anything like that. It's different. It's just basically labeling your x and your y. Now it doesn't actually matter which y you write first, as long as you write that for that corresponding x first. And I'll show you what I mean here on this first one. So I'll do it both ways. So our y's in this case are 2 and 3. So you can write 2 minus 3, or you can write 3 minus 2. It doesn't matter. But the thing is, then you have to put the x coordinates in that same order. So if you wrote 2 first, then you would have to write 1 first in the denominator. So the denominator would be 1 minus 4. Whereas when we wrote 3 first, we would have to write 4 first in the denominator, 4 minus 1. You'll see that both of these come out the same way. 2 minus 3 is -1. 1 minus 4 is -3. Here we have 3 minus 2 is 1. 4 minus 1 is 3. You can't do anything with 1/3. That's simplified. Here, you have a negative divided by a negative, so that would come out as +1 over +3. Same slope, so it doesn't matter which x or which y you put first, as long as you put that corresponding x first. So let's try these out. In this case, our y's are 5 and 2. So I did my 5 first, so that means on the bottom I'd have to do my 3 first. 3 minus 7. 5 minus 2 is 3. 3 minus 7 is -4. You don't typically write the negative in the denominator, so either write it out in the middle or put it up top. -3/4 is the slope. All right, we're going to do this last one, and then I want you to try some out. So here, if I wrote my 6 first, 6 minus 2, then I would have to write my 4 first, 4 minus 0. 6 minus 2 is 4, 4 minus 0 is 4, and 4 over 4 is just 1. Now, if you end up with 0 in the numerator, 0 divided by anything is 0. If you end up with 0 in the denominator, that's going to be undefined. You can't divide by 0. So I don't think that happens on any of these 6, but it will happen in the future. All right, so pause it here, try them out, and then check in with me and make sure we're getting the same answers here. Hey, if you have minus negative, remember you're really adding a positive. So this is really 3 plus 2, which is 5 down there. Negative 4 minus 5 is negative 9. Negative 9 fifths. 7 minus 4, 6 minus 2, 3 over 4. And over here, 5 minus negative 5, 4 minus negative 2. That becomes plus plus on both of those. So 10 over 6, which you can reduce that to 5/3. We got 3 more of those. Two minus negative 2, 4 minus negative 3. Negative 2 plus 2 is 0. Divided by 7 is 0. 9 minus negative 2, 4 minus 4. Oh, it does happen. All right. 11 over 0. You're going to write undefined for that. And negative 4 minus 2. Whoops, that's an 8. 8 minus 5. Negative 6 over 3, which is negative 2. Let me double check. That might be it. Oh, here we go. So we have another one like those ones we started with. Find the rate of change. Explain what it means for each situation. Pick 2 points. I'm just going to pick here and here. So look at the labels. It went up 3 points over 1 basket. Which means they scored 3 points per basket. Great. They're training 3-pointers. I mean, obviously. If you look at the labels, it kind of gives it away. Here we have distance in miles over time in seconds, so it's going to be miles per second. So let's see how many miles they're going per second. They went up 2 miles every 10 seconds. Now that would reduce to 1/5. So they go 1 mile every 5 seconds. That's pretty quick. I know you're probably thinking, looking at the top label, it probably says how fast Mr. Plant can run. Oh, distance sound travels in air. Pretty close. And then over yonder, we are seeing feet per second. Okay. So if we choose anything here, let's go with this and this. It went from 48 to 32, which it dropped 16 feet per second. And then that went in 1 second. Okay, so the speed is decreasing. (16 feet per second) or you can say per second squared, or you can say every second. Yeah, that one was a doozy. We did it.